it's our final session of the day. We've got Keenan Johnson with a demo. Well, let's learn a little bit more about that. So Keenan is the founder at Ribbit Network, which is building an open source IoT greenhouse gas sensor for climate. Keenan started his career tackling the biggest, most innovative project he could find, space exploration. He worked on satellites, space first aid, Mars rovers, and rockets. He left SpaceX to found Impossible Aerospace and prove to the world that it was possible to eliminate carbon emissions from aircraft today. After Impossible, he joined the early teams at several startups, including Bedrock Ocean Exploration, developing autonomous underwater vehicles to map the ocean floor, and Third Derivative, an accelerator for climate innovation. I get it, Third Derivative. That's so good. He also serves on the advisory board for several startups and nonprofits. All right, take it away, Keenan.
Hello, everyone, and thank you, Alex, for the kind intro. It's good to see everybody. Good afternoon or good morning, wherever you are in the world. Hey, I'm Keenan. Alex just gave a little bit of an intro, so I won't spend too much time espousing about myself, but I'm the founder and now executive director, which sounds really fancy, but that's just the title for the person in charge of a nonprofit. Of Ribbit Network. And Ribbit Network, we're a nonprofit building open source hardware, software, and more importantly, a community around citizen scientists who are passionate about climate change and want to use technology in a productive way. So I'm going to this is a demo, so I'm going to breeze through a couple slides though, just so like people have some context of what I'm talking about. So Ribbit Network, like I said, we're building this missing map of CO2 emission sources through open source crowdsourced sensors. So this is our frog. He's sort of the mascot. I'm wearing my Ribbit Network t-shirt, which has him on a skateboard. If you don't have any questions, Alex and I were just discussing backstage that the frog needs a name and is yet unnamed. So we'll take any suggestions for frog mascot names. The problem statement for Ribbit Network is the problem statement of climate on Earth. And we have a big problem with humanity in that we have been creating all these crazy greenhouse gases. And we're pumping them into the atmosphere at like these astronomical rates. And the climate change is really interesting as a problem. Pick any societal problem that you want, and there's always a lot of debate about like what's causing like the problem. And climate is actually kind of unique because we don't have, there's zero debate about what is causing the problems that we have, which is actually really inspiring for us as scientists and technologists, because we know exactly what the problem is, and now it's more of an engineering problem to go figure out like how do we engineer society to go fix that problem. So at Ribbit Network, we imagine this future where us as society, citizens, corporations, governments, nonprofits, we can all work together with open data on where these greenhouse gas emissions come from to drive effective climate action and create government policy. So what we would love to have is this missing map for climate. So we should be able to pull up a like weather radar style kind of map exactly like this that shows, hey, where are all of the climate emissions in real time right now? So if you're familiar with projects that do this for particulate tracking, it's like Purple Air is probably the largest example of this kind of network. That's particles in the air, which is pollution, which is really important for human health, for example, but not really related towards climate change. So we need that for greenhouse gases. So Ribbit Network started off as kind of a project that just I was doing by myself, kind of alone on the internet. And I was like, you know what, I should just put this on GitHub because it's just like a place for it to go. And I started talking to more people about it as I was sort of just learning about the project. And it's sort of grown into this larger project, which I'm really excited about. And so now we're an official nonprofit. So we have a great organizational container that's aligned with our mission, which I'm really excited about. You can see some pictures here of like our website on the top right. That's ribbitnetwork.org if you ever want to go check it out. We have been able to build a really great community in Discord as well. So if you go to ribbitnetwork.org or I'm sure we'll put links in the Hackster Discord, or you can find links on our Ribbit Network Hackster profile, or if you just put in Ribbit Network into Google or whatever search engine you prefer, you'll find us. And you can come join us in this community, which is really important. And that's important because, you know, this project is built for you, by you. So we have a great set of volunteers who have all contributed both in technical and non-technical ways. So whatever like genre of contribution that you want to do, whether that's on the technology side, which we desperately need. So we're looking for all kinds of software or hardware engineers to come help us build the next generation of these sensors. Or if you're more like on the soft skill side, like you want to do outreach to local schools, for example, to think about like, how do we get one of these frog sensor kits into a local school? That is just as great. And we would welcome you to come. So come join us in Discord. We have a core team who sort of, you could think about them as serving the roles of maintainers if you think about a technology only open source project. And if you're interested in that kind of thing as well, let us know. So this is a demo, right? And so I'm going to talk a little bit about frog sensors, but I'm just checking the questions here. So we've got a question for how do we reach out to you about participating? Great question. You can find me in the Hackster Discord or on Hackster, the website. But the best way probably is to either come on our GitHub, which I'll show in a second. So if you search Ribbit Network GitHub, you can find us there. That has my GitHub profile and email and everything. And we have a discussion forum hosted on GitHub, which you could contact. But probably the best way is to join the community via Discord. And so I'll make sure that link is here, but it's linked on ribbitnetwork.org. There's a big like join the community button, and that'll take you into the site. Perfect. So Ribbit Network frogs. These are our frogs. I'm going to show a quick video of what they look like and what it takes to physically assemble it. It's, you know, I'll talk about the different sensors that it has in a second, but here's like the quick short video of what this frog looks like to put together. So it's really awesome. We've been able to 3D print the whole enclosure. So the enclosure that you see is something that our open source community has designed. You can 3D print the whole thing. All the electronics are pretty standard things. So this video is a little bit older than our current version of the frog, which currently uses a Raspberry Pi CM4. This one you'll see is a BeagleBone Green wireless gateway, which is a little bit of a older school board from Seed, which is great. And Seed, if you're listening, keep making that board because it's awesome. You can see us plugging in all the sensors. It's designed so that you don't really need any special tools other than perhaps the 3D printer to print the enclosure. And you just need basically a screwdriver, pop everything in, put the sensors in into this top bit, which you can see the lid going on there. And so I'll just pause this real quick just so you can see what's happening. So in this bottom section, kind of the rectangle at the bottom, that's where our single board computer is. It's a Raspberry Pi CM4 right now. And in the top bit, which you saw us just put the lid or like the head of the frog on, that's where all the sensors live. So we've got 3 main sensors that I'll show in a second live. But there's a GPS sensor, a barometer, and then the most important one, which is our greenhouse gas sensor today, which is CO2. So we use a near infrared detection method there, which is the most accurate sort of like cheap CO2 sensor that you can get. Although I just saw a question in the audience that the SCD30 is quite expensive. And yes, that's true. It is expensive, and we're trying to figure out if there are alternate sensors that are cheaper than that can still achieve sort of the goals of science that we have, because ultimately we want this big data set to be useful for science. And that's still a super big open question in terms of like, what are the cheaper sensors that can sort of balance that cost versus science accuracy question. And so if that's something that you're passionate about, come join us and like share your expertise. The other awesome thing about that SCD30 is it includes a really accurate temperature and humidity sensor, which is really important for post-processing of that data. So that's like the physical assembly. And unfortunately, like I wish I had time to like build it physically, which it doesn't take too much longer than our demo slot right now, but just a little bit longer than we actually have. So we won't be getting into that today. But I will show kind of the setup for all the software and electronics as soon as I can advance this slide. Oh, I guess that's my last slide because now we're getting into actual fun demo stuff. So you've put it together physically. Like, what do you have to do to build a frog sensor? The first step that you would do probably if you're coming into this is you would go to our GitHub, which I'm showing here. This is our sort of organizational page. This is a super great place to start out with if you're looking for like, how do I get involved with a project? I'll put a link right here in the chat, which I think went to everyone. Maybe it just went to the host. I'm not sure. The backstage people can maybe help me share the link there in the chat. But this is ribbitnetwork.org. There are two main sections of this website. There's the frog sensors and then the data dashboard, which hosts all of that data and collects it. And I'll show that in a second at the end of the demo. But if you go to this frog sensors page, this has kind of all of our information about like, here's the frog, here's what's going on. All of the hardware and software that's needed to build a frog lives here, including this really great set of assembly instructions. So if you wanted to build a frog, you would come in here and we give you everything that you need for how to do it. So there's the parts list that you need. We talk about what it takes to 3D print the enclosure. And then we give you all the instructions for how to download the software, for example, to flash onto the Raspberry Pi. And I'll just show it briefly that we kind of covered in the video, but there's also great instructions here for like how you physically build it. And we spent a long time trying to make good instruction sets here. And that's a lot of the work that the community has done. So I'm super thankful to the Ribbit Network community. But so software. So on kind of my desk here, which let me maybe disable my virtual background here so you can see what I got going on the desk. You'll see here, got Raspberry Pi CM4. So I took it out of the enclosure, so we don't have one of the 3D printed enclosures here, just because that's kind of fun and like kind of leans into the Hackster like maker vibe. So, Raspberry Pi CM4, here's our little antenna. That's the fun fact. That's why we chose the Raspberry CM4, is because it's one of the only devices that you can get that has an FCC certification for like a nice high gain antenna like that, which is really important for our project because our sensors need to go live outside where people's home Wi-Fi is traditionally like sort of weak. And yeah, so that's super important, even though they're super hard to get right now, purchasing wise. And then you can see here, I've got the little sensor stack. So kind of on the bottom, it's sort of hard to see, but this is the SCD30. That's that CO2 temperature and humidity sensor that I talked about. We also have the barometers, that's barometric pressure, and then our GPS sensor. And these are all great. We're using the SparkFun sensor boards for all of the, or Adafruit, sorry, the Adafruit boards for all of these. So you can find links to that on our bill of materials on the site and figure out how to buy everything there. But so how do you get software into this thing? We use this really awesome software project called Balena, which is an open source hardware and software company that does fleet management for IoT devices. And one of the really awesome things that they do, which is super helpful for us as a open source project, is they have this concept called an open fleet, which is a centrally managed fleet of frog sensors. So, us as the core team on Ribbit, we create the software on GitHub, and then we publish sort of the good releases of Ribbit Network software. And then anybody who wants to join their device up to the Ribbit Network Open Fleet can image an SD card for the Ribbit Network Open Fleet, put their device onto the network, and then you'll be joined up. And so you'll get all the software updates for Ribbit Network forever, which is really great because it's super difficult to think about like how you would do like a community managed open source fleet, if you had to say like email everybody like, hey, update your software now, like go and flash your Arduino, everyone, like please do that because we've made some sort of critical change to the software. Like that would be very difficult to do and not very much fun for everyone probably. So balena has really been like a critically awesome enabler for our project. So I was going to show what it would look like to do that here. So let me go. So the way that you would start, and the links to all this stuff are in the GitHub instructions. But you would go to balena. You can look at all the open fleets here. There's a bunch of other cool open fleets that you should go in and check out if you're interested, other than Ribbit Network. And we'll search for Ribbit Network. And you'll find here Ribbit Network. Cool. So let's get started. And there are more detailed instructions than this, and I'm going to kind of breeze through it for the demo. But you select your board. So I'm going to select a Raspberry Pi CM4. How do I want to connect? In us, we're using Wi-Fi. And what you do here is you enter your Wi-Fi credentials, which I'm not going to do because this is saved on the internet. But I've done this previously that I'll show in a second, and then you can either click this button right here, which will, if you have balena's SD card flashing program called Etcher installed, it'll automatically flash your SD card that you've got, or you can download that image and flash it yourself via Etcher. So I downloaded one before. I've got my SD card here. I can pop this guy into the computer, and let's see if I can switch my window that I'm sharing. Okay, so now you can see my screen. So what you would do is you'd open Etcher. I'm going to flash from a file. So this is that file I just downloaded. Going to select my SD card, flash. You have to confirm your admin password. And this is flashing the Ribbit Network software onto the SD card right now. So that'll take a few minutes. I won't show the whole thing because I've done it before. But it's super easy. So you just do this flashing process, put it into your assembled Raspberry Pi here, turn it on, and it should automatically connect to your Wi-Fi network. It'll download the latest Ribbit Network software. And then all you have to do is go install this thing outside and let it do its thing, and it'll start collecting that data, which is awesome. So, here's a device that I set up earlier. This is sort of the balena backend dashboard, which if you haven't seen this for a balena device, it's super awesome. You can see here, this is kind of the most important part, this like kind of middle right section, logs. If I expand this, this is each of our data points for a CO2 measurement. So you can see, here's what the CO2 ppm is. We also have temperature, relative humidity, the GPS obfuscated position. So the device truncates the GPS position, so it's not possible to locate you 100% accurately, like the most accurate of the GPS. But for science, we need to be able to locate the GPS permission or like location within about 2 or 3 kilometers. So we truncate the GPS position to that accuracy. And you can see this is just sort of the console log. And what the Frog is doing is it's publishing that up to our centralized database, which is also hosted on InfluxDB, which is another great open source project that we support. Yeah, so balena is awesome. One of the great things that you can do, in addition to like the devices just downloading firmware updates on their own, trying to use the Wi-Fi most efficiently, you could SSH into a device if you wanted. Balena uses Docker containers. We're running Docker containers on the Frog. So you can see the 3 of them here that we're running. One is for Wi-Fi Connect. So if the device can't connect for Wi-Fi for some reason, it will host a captive portal where you can go in, connect to the device directly, and rechange your Wi-Fi if you needed to later. We've got another container which handles talking to some of our GPS sensors, and then our CO2 sensor, which is like aggregating all that data and sending it up to the cloud. And you could look at logs for each of these Docker containers, start and stop them, SSH into them, the whole thing. So kind of the last part of the demo that I'll show, this is the ribbitnetwork.org site, which you could join. As I mentioned, we've got two really important links here. One is for joining that community. So that gets you into the Discord, and that's a really great way to start. And the other way to start is to start building your own frog sensor. So if you click this button right here, that'll take you to the instructions for how to build your own frog. But if you click this other button, view live data, this is the other cool feature, which will take you to sort of the live map of where all the frog sensors are. So we've got, I think, frogs in 6 or 7 countries around the world now. And, we're still a pretty small organization, but hopefully we can blanket this map, over the years. So I'm going to zoom into a sensor in Seattle, where I live. And you can click on a sensor. And so this is that exact data that you saw coming through in the console earlier. And you can look at these awesome graphs of what's the CO2 concentration and temperature, maybe for the past day, barometric pressure, humidity, and you can see all this stuff like really actually changes quite a lot over the day. And hopefully the goal is like once we have enough sensors down in a particular area, we can merge wind data with the CO2 concentration data and start to build some really awesome heat maps, which is exactly what your local city council people or state government or federal government would need to be making the laws and the policy that they're making about climate based on data instead of assumptions, which I think as scientists and like engineers, we can all relate to is like, that's the future that we want. So that's kind of the end of the demo. That's like everything that you need to do to get a frog set up and running on Ribbit Network. And I would love to take any questions that folks have. So I know we had a few come in on the chat here. So I think we already answered the one about participating. So somebody, Leonardo asks, what are the pros and cons if we compare Ribbit Network with the CO2 data already collected by satellite images? So a great question. One of the big pros is that the satellites are awesome. And I think if we try to imagine like what the future of climate and greenhouse gas monitoring is, we have really great like analogies that we can look at. So weather monitoring, so like rain or temperature is a really great analogy, which, we've been doing that for thousands of years. Humanity has been trying to guess what the weather is. And the way that that's done right now, which has gotten really accurate, is we've got a combination of satellites, aircraft, and a huge network of ground-based sensors. And the weather models that we use take in all of that data and try to combine it into the best version of the weather prediction. And I imagine that that's what the situation will be for climate and greenhouse gases in the future. So Ribbit Network and the satellite monitoring solutions both have pros and cons. Satellites, for example, can look anywhere very easily, whereas ground-based sensors, you have to go physically deploy something on the ground. The ground-based sensors have the benefit where they can sit and collect data in one spot 24/7 all day long. The satellites, usually you have to task them to look at particular parts in different times. And so I think that the future is we'll combine both of them. And so Ribbit Network kind of fills the gap, and there is really no ground-based monitoring system right now. Other questions. Was finding funding a challenge when you were starting out as the nonprofit? I would say yes, and is still a challenge. So although Ribbit Network is a nonprofit, we are still relatively new. We filled out the paperwork and got approved as a nonprofit really about 1 year ago or slightly less. So we're still quite new, and we're still kind of looking for like what funding exactly looks like. So like, I'm a volunteer for Ribbit. Nobody gets paid on the project. I would love for a future where somebody does get paid. And so if you're have funding opportunities that of for Ribbit who would fund this kind of a mission for building sort of these citizen scientist educational experiences. One of the things that we're really excited about doing in the very near future is putting together Ribbit Network kits. So frog sensor kits and partnering with school districts all around the world to go in and build an experiential curriculum about like, here's what it means to like build a sensor? Like, what is 3D printing? What is software and hardware? How does that relate to a societal problem that we experience? All of that is a super fundable activity that we could do. And so I would say funding definitely still a challenge. Another question, what's the cloud application you are running? I think so, depending on which cloud you're talking about. So sort of the stack is like balena is like IoT fleet management. The database is InfluxDB cloud. And then the website that I showed, the sort of front end, that's a project. It's basically a Flask app. So Python Flask, if you know it, there's a project, Plotly Dash is a web hosting framework, which kind of wraps up some of the nice plotting libraries into a good front end framework, which I would definitely recommend checking out. And you can see what that looks like if you go to our GitHub. All that source code is available on the dashboard, which I didn't show. And then I think last question, is it from Robert, is it feasible to use a fairly heavyweight device like the CM4, running the balena software as a gateway, lower cost devices using LoRa to the CM4 as a gateway? Yes, I think that is super possible, Robert. And I think that kind of thing starts to become really interesting. Like once you have a lot of Ribbit Network sensors put down in a particular area, that kind of thing gets super interesting. And we would love to look at like all kinds of interesting technology, communications, like there's a lot of cool work being done in mesh networks right now. And thinking about how we would reasonably deploy like a set of Ribbit Network sensors in a super low cost way now, but also enables low cost deployment in the future via citizen scientist is a super interesting, like challenging problem. And if that's something that you're super interested in, like come join us and help us build out like what that should look like in the future, because I think there's all kinds of cool technology that we could build and we would love to. One of the things that we are really excited about doing in the future is building a solar powered version of this frog, which aligns very nicely with, you know, kind of the ethos of the project being around climate, but is also super technically challenging. You know, there aren't that many good solar powered open source products like this, I would say, that you can look at exactly how it was engineered. Most of those come out of commercial companies, and it's fairly obtuse. Like what are the engineering choices that they made to get there? And so we hope that we can sort of be that like roadmap of like how you would do that in open source. But the only way we'll do that is like through good quality volunteers like yourself. And I think we just have like 1 or 2 minutes here before I wrap up. But hey, Jessica.
Hey, Keenan. Any last thoughts for your session?
No, thanks for listening, everybody. You know, you can feel free to find me. I'm on Discord, on the Hackster event Discord here, the Ribbit Network Discord. Like I said, you can find us at ribbitnetwork.org. We posted some of the links there. Come join us because we'd really like to help you to build the future that we all imagine. So thanks, everybody.
Thank you, Keenan, so much. If you have any other questions for Keenan, be sure to hop on over to the Discord, ask him there. He also has a community page on Hackster with a discussion tab, so you can continue that conversation with Keenan and all the people at Ribbit Network to see what they're building and see when solar's coming next. So looking forward to that. All right.
Yep.
Thanks, Keenan.
Thanks all.